Hello and welcome to another video. Today we're going to be focusing on Decode Ways in TypeScript, the next problem in the Blind 75 in TypeScript. And in this problem, you're given a message containing letters A to Z, and it can be encoded in numbers using the following mapping, so straightforward 1 through 26. And to decode an encoded message, all the digits have to be grouped, then mapped back into letters using the reverse of the mapping. For example, 11106 can be mapped into AAJF with this mapping, and KJF, and so on. And given a string S, you want to return the number of ways to decode it. Test case is generated so that the answer fits into an integer. And so, for example, when you have 12, you can either decode it in like this, A, B, or you could take this whole 12, which is an L. So we can either have AB or an L. And for 226, we can have a few different mappings, right? So we can do one letter at a time, which would be BBF. Also, we could do 22 and then 6, which would be VF. And then we could also do 2 and then 26, which would be BC. And let me see if I'm missing anything. I don't think so. And then the next one, we have 06. And we can't actually decode it because we can't decode this 0 because nothing maps to 0. But you can have stuff that will have a 0 that will be decoded. So you can't just say, like, if I don't have a 0, let's just return 0, right? Because what if your string is this? Then this is obviously decodable into whatever character is letter 10, right? But you just can't have, if you do have a 0, you have to make sure that it's part of a 2-letter, or like a, a letter that's a double-digit letter, like 10 or 20 or so on. So how do we do this problem? And I'm going to kind of briefly say that I'm going to talk about the memoization solution, but I will say that for all of these problems where your states rely on the state right after, you can actually do a bottom-up DP with O of 1 space. So I'm not going to go over that here because this is more focused on TypeScript. Maybe I'll make a Python video about it in the future, but it's kind of like house robber where you can have memoization, then you can have bottom-up, and then you can finally have a constant space solution, because essentially all of your values, like our solution here will be O of n space. All of your values rely on the values right after them, so you can just have two integers record the values, and that would totally work. Okay, so we are going to focus on the memoization solution in this case. And so for the memoization solution, it's going to be pretty straightforward. So essentially, when you have some numbers, like let's just say we have like 980622, when you're figuring out how to decode, at every single number you have two options, right? So you can either take that one number, where you just say like, okay, this 9 will map to whatever letter, and then we'll just move on to the next index, or you can map it to a 2-letter, or like a number that represents 2 letters, but obviously 98 you can't, so the numbers that represents 2 letters have to be from 10 to 26. So we can just say whatever number we're at, if it's a 0, then we can't take that one letter because nothing maps to 0. But if it's a 1-digit that's not in 0, we can say, okay, well, we have the choice to either take that, or we can check also the 2-letter sequence and make sure it's in this range, and if it's in this range, we can take that too. And so this is the common thing of climbing stairs, where you have two options, right? And we're going to write that down. So you have two options: either take 2 digits or 1. And so the way to figure out the total number of ways you could do that is it's just as every another problem. It's number of solutions after taking 1 digit plus number of solutions after taking 2 digits. So these are your only like 2 things you can do, and like this is really common where you have 2 things you could do, and the number of total solutions is just the number of ways after picking path A and the number of ways after picking path B. So essentially what we would do is we would say like, okay, so for this thing, we'd say, okay, we can take 1 letter, in which case we would say that's just going to be over here now, right? And we can't take 2 because it's not in the range, but let's say we're over here, so we can only take 1 letter here, and then let's say we're over here. So this would actually be one that wouldn't be able to get decoded, because this 0 has to be part of like a 2-letter sequence. So you'd say like, okay, I can take the 9, but I can't take 98. I can take the 8, but I can't take 80. And then once I get to the 0, I would have like a no solution. Well, essentially, let's write down our states for the DP. So we're going to have states, and the state is just an index. So that's pretty straightforward, whatever index we're currently on. Then base cases. So what are our base cases? So base case is we are out of bounds, right? So if we go through this whole word, what should we return, basically? That's the question. And so we can just return 1, because there's only one way to get a word with no letters, right? So we're going to return 1 as like our default, where we're out of bounds. And then finally, let's go through the, or I guess that wouldn't be in there. It would be in our recursive case. So base case, out of bounds, we went through the whole word. We're just going to return 1. Obviously, there's also caching, because you can get to the same part multiple ways. Obviously not in this word, but you could, let's say you could take these 2 and then these 2 you'd get here, or you could do like 1 at a time and so on. Obviously, like I said, in this you can't, but if you had something like a bunch of 1s, you can see how you'd get to the same state multiple times. So we are going to have caching, and then we are also going to have a recursive function. And so what are our states in the recursion? So A, take 1 letter, but we can only do this, it's non-zero, right? We can't take a 0. Or B, take 2 letters, assuming there are 2 left to take, and those 2 letters are between 10 and 26, right? So for example here, we can't just take 98. And that's pretty much it. So you just, this should be recursive, but essentially, yeah, you either take 1 letter or 2 letters, and you check if you can, and then you just return the DP of those, and you just add them together. So the result is going to be A plus B, and then we just cache. So pretty straightforward, and like I said, you can make this bottom up afterwards. I would encourage you to if you want, and you can't think there is a way to do this bottom up space optimized, because in any time because essentially here, if you take 1 letter, your next index will be index plus 1, right? So I'm just going to write that here. So your next index will be index plus 1. And if you take 2 letters, your index will be index plus 2, which looks just like climbing stairs. So you can look up the climbing stairs space optimized bottom up, and this is pretty much the same thing. I'm not going to code that one up, but it's essentially the same way, so it's good practice to do that. But this is more TypeScript focused. So we are going to do the memoization solution with an index, a base case where we're out of bounds, and this recursive solution. So let's code that up now. And here we have it. And we are actually just going to full screen it. Okay, so we are going to make a cache. So we are going to say constant visited. And if you think about it, what do we want to record? Well, we just want to record an index, right? So it's going to be a record, and it's going to take a string as an index, right? The key should always be, actually, in this case, I don't think it needs to be a string. I think it's going to be a number, right? It's going to be a number and a number for this record. And we're going to make it this, because the index will be a number, and the this should be comma. Yeah, so essentially, like I said, the way, and in my other videos, the way a types for an object works is you can make it a record with a type for an input and a type for an output if you don't need like specific exact values. And if you want specific exact values, then you can just make a new type. But in our case, we're just going to take a number and a number. Now we are going to make another function called dp or whatever we want. So we're going to say const dp equals, it's a function that's just going to take an index, which will be a number, and it will return a number. And yeah, I think we're missing something. Const dp equals something, something. Yeah, we're definitely missing something here. I'm really bad at these types, that's for sure. Const dp equals something. Yeah, let's see here. We are definitely missing something. So this is saying it's fine. Const dp equals something. Oh, right. So this is actually fine. It's because we haven't returned anything yet. So if we just type like return 3, this is fine. Yeah. Okay. Cool. So what are we going to do first? So remember, we are going to check the base case. So we can say if index equals length of s, or s.length, then we are just going to return 1, as in that's fine, that's a valid state. Okay. So that's a base case. Now we also need to check for the cache, so we can say if visited index, then we can also return that, return visited index. Okay, so those are our base cases. Now we need to see if we can get one number. So we can try to get one number, but essentially what we have to do is we're just going to set some variable equal to the result. So we're going to say let result equal 0 for now. And essentially we're going to say, let's just get whatever index we're at, let's get that number. And if it's 0, then we can't recurse. Otherwise, we can recurse into taking one number. So we can say if s_index does not equal 0, because these are strings, then we can try to recurse. So we can say result plus equals dp of, and remember if we take one number, it'll be index plus 1, and that's pretty much it. Okay, so now we have to check for taking two numbers. So we have to make sure that this is not out of bounds first of all. So if index does not equal, like if we actually can get something long enough, I think I want to convert, like, yeah, I think what I want to do is just make a slice here, because actually, let's think about this, right? So the problem with comparing strings in JavaScript is if we have something like 10 and 26, I think 26 will actually be greater, and we're not. So if we only take two-digit strings, I don't think we're ever gonna have an issue where we have a comparison error. Yeah. So I don't think we even have to convert them, because like anything with 2 will be bigger than anything with 1. The problem is something like this will be greater than this, but we're never going to run into that case. So if we're never run into that case, we just want to make sure the index is actually in-bound. So if the index does not equal s.length minus 1, right? And we want to make sure that it's between 10 and 26, so we can say like s_index. We actually do need to slice, I think. Yeah, I think we do need to slice. So let's just actually do slice it. So we're just going to say let maybe like toNumber or something, or const. But we definitely do need to slice. What do we want to call this? I guess we can call this like 2 letters or something. I don't know. Or like double digit. Sure. Equals. This is going to be s.slice. And then we are going to be slicing from index to index plus 2. So we need to make sure that it's actually 2 letters. So we can just say if double digit length is equal to 2, not 1, and double digit is less than or equal to 10, and double, like I said, we can't obviously convert it. I guess maybe we should convert it, right? So I think we can just convert it. So we can say like this number, we can just convert it, I think. Let's see what issue we have here, actually. It sucks that I can't see it, which is kind of annoying. I wonder if I can do this for now. Does this work? I think there is like a problem with this slice thing. Maybe I can't do it in place. Yeah, so let's just try to do this, and let's see if I am allowed to do this number. I think actually it might need to be uppercase. Not exactly sure, but let's see. Double. That's the annoying thing about this. Yeah, there we go. So we can do that. Okay. So we're going to make double digit, and then we are going to, I wonder if I can actually do it here. I don't see why not. Okay, there we go. So now we have a number. So now essentially we can just check if double digit is greater than or equal to 10 and double digit. Yeah, that is the annoying thing about doing leak codes in JavaScript is it doesn't give you the error, which is really annoying for TypeScript, to be honest. So that's why this one might have been better doing VS Code, but it's okay. Okay, double digit is less than or equal to 26. Then it's a viable number, so we can just say res plus equals dp index plus 2. And that way, even if we got like Like let's say our numbers was like this, and we were at the last number, we would just get a 4. So that would be fine. Okay, so we get both of those, and then, yeah, so we got a 1 if it was valid, we got a 2 if it was valid, then we simply need to store it, we need to cache it, and we need to return it. So we can just say visited index equals res, return res, and now we simply need to call our DP function with 0, and we need to return that. So return DP 0, and let's see what happens. Okay, nice. Surprising. And I will be honest, I didn't code this one before doing this video, so. Okay, so it looks like it's not extremely efficient TypeScript-wise. Like I said, you can definitely make it more efficient if you use bottom-up, but I think it's still fine. Like, I think they're gonna be pretty close. And also, like I said, when I did this TypeScript, I got stuff that was all over the place. So it's hard to say like how efficient it actually is. But yeah, I guess what we can try to do is to make it a little bit more, since we are like doing TypeScript, we could just store it like this instead of a number, and then we could try that other thing that we were going to try. So we could say if double digit length equals 2 and double digit is greater than or equal to 10. I think you can do a string comparison. Okay, let's try that. I think this should still work. And it does. I wonder if it'll be faster. No, it's still about the same. Okay. And yeah, I think with TypeScript, I'm not super concerned about like performance because it is kind of all over the place. So sometimes it's good, sometimes it's not. Like I said, you can definitely make this faster using bottom up with 0 space, but I don't see how that would be faster. I don't see how that would be faster time-wise. Maybe like slice is a little bit longer than some other operation, and this is kind of like a basic-ish problem. So these small things are going to add up. But yeah, let's just go to the time and space complexity here. Okay. And let's actually, no, that's fine. Okay, so for the time and space, essentially this should be O of n for the time because we are looping through every single index, and then at every single index we are only going to 2 new indices, and then we are only slicing a 2-digit array, so this is basically constant, and then we are only doing 2 operations, so basically constant, assuming you cache. Yeah. And then we are going to look at the space, which should be O of n as well, because we have this visited hash map and inner DP, and there can only be index number of states in here. And like I said, if you want to look into doing the iterative one, or not iterative, but bottom-up DP with constant space, just look into climbing stairs optimized, pretty much the same thing. And that would give you good practice there, but not going to do it in this video. So yeah, I think that's it for this one. Yeah, hopefully you like this one, and if you did, please like the video and subscribe to the channel. And thanks for watching. I'll see you in the next one.